Good morning, everybody. I think that we can start with this webinar. Welcome to everyone to yet another EHPA event. My name is Sonia Bianconi. I am EU Projects Manager at the European Heat Pump Association, and today we will be diving into a very interesting topic, EU perspectives on industrial heat pumps, and we will go through some non-technical barriers and opportunities that either prevent or encourage the uptake of this technology. I will be honest with you, it hasn't been easy to find the speakers for this webinar, because industrial heat pumps are still not a widespread technology, and there is not much work done on this specific topic of studying barriers and opportunities. But yet, nevertheless, together with my colleague Irene, that is right in front of me, we've managed to build up a very nice agenda for you. Well, at least this is what we think. So we will have a 10-minute opening speech by Veronica Wilk that is going to give us an overview of the European perspective. And then we will have our panelists, Jan Kinkepoix from DEC in France, Jonathan Vandenberg from the Netherlands Environmental Assessment Agency, Fabian Bühler from the Danish Energy Agency, Padraig O'Reilly and Seamus Owen from the Technical University of the Shannon and Federene. At the end of these presentations, we will have a panel discussion among the speakers, and this event will be closed at 12. So as you can see, there are no coffee breaks, so please get your coffee, get your tea, get your water, and let's start with this webinar. So before leaving the floor to Veronica, I would like to introduce some housekeeping rules. As you can see, you do not have the power to access your camera or mics because we are on Teams webinar. Nevertheless, you can put your questions, if you have any, in the chat during the event, and the speakers can also answer your questions throughout the event. But if some questions remain unanswered, we can leave them for the Q&A. And finally, as you can see, the recording of this webinar is being recorded, and the recording will be shared with you together with a master presentation at the end of this event and in the following days. So if you have to leave early, don't worry, because you will have the material in time. And before giving the floor to Veronica, I'm happy to tell you that this webinar has been organized under the framework of two Horizon Europe projects that aim to foster industrial heat pumps in Europe. These two are called Push to Heat and Spirit. They both kicked off last year. And EHPA is partner of these two projects, and I'm very happy to briefly introduce these two to you. So we have Push to Heat, whose main objective is to push forward the deployment of industrial heat pumps at EU level, and it will do so by demonstrating four different technologies in four different demonstration sites, two in the paper industries and two in the chemical industries. And it has a duration of 4 years, and it counts 20 partners from 6 European countries. And then we have Spirit, that stands for Implementation of Sustainable Heat Upgrade Technologies for Industry, and it kicked off as well in September last year in the beautiful beach of Petten in northern Netherlands. And it has 3 demonstration sites, 1 prawn processing in Norway, 1 sugar production plant in Belgium, and a paper plant in Czech Republic. It counts 17 partners from 8 EU countries, and it is led by TNO. But without further ado, this slide, you will see it also at the end of this presentation. So if you want to know more about these two projects and follow them online, please scan the QR codes, and it will redirect you to websites, social media pages, and the possibility to subscribe to the newsletter. And without further ado now, I'm very happy to introduce Veronica Wilk. Veronica is Senior Research Engineer and Thematic Coordinator at the Center for Energy at AIT, Austrian Institute of Technology. and she's also chair of the Industrial and Commercial Heat Pump Working Group at EHPA. She leads the research field efficiency in industrial processes and systems, and works in national and international research projects on industrial energy efficiency and the integration of heat pumps. So please, Veronica, the floor is yours.
Thank you very much. Thank you for that kind invitation. And also thank you for setting up this webinar with this interesting topic of barriers and opportunities. And I will give you now the next couple of minutes an overview on industrial heat pumps in Europe. And I will dive into some of the barriers. And I also look forward to the other presentations to see the different perspectives. So I want to start with the waste heat and the heat demand, because those are two important ingredients for industrial heat pumps. This is an illustration that was published 2 years ago by Marina and his co-authors, and they did an analysis of the waste heat potential in 4 industrial sectors: in the food, in the paper, in the chemical, and the refinery sector. This is what we see here on the left. And they also analyzed the process heat demand that we find in those sectors. And when we compare these two, also with the temperature scale that is here on the x-axis, there's a clear picture. So we have a lot of waste heat available below 40 degrees C, and the process heat demand starts around about 100 degrees C and increases even further when the temperature increases. And the technology to bridge this gap, these are industrial heat pumps. So we can recover waste heat and provide process heat at a higher temperature. This is an overview by the IEA that was published in their report on the future of heat pumps last year. And this overview shows us the heat supply temperatures that are available and the technology readiness level of these technologies. The technology readiness level is a concept coming from research and describes the way from the idea to the first prototype to the first product to market implementation. And what I like a lot about this illustration from IEA is that they expanded the TRL scale to add 2 more of these levels that are very important for the industrial end users. And this is TRL 11, what we find here on top of the list for heat pumps supplying temperatures below 80 degrees. And they have already reached a proof of market stability. So this is a commercial product that is already spread in industry. If we go to higher temperatures below 100, it's TRL 10, as they call it. That's commercial competitive, but not yet deployed at a large scale. And when we go to further higher temperatures, then we come to lower TRL. So we see a lot of research work here, lots of demonstration work, and this is very important to establish new technologies in industry, to do that in the framework of a demonstration setup where all the partners can share the risk together and show that these implementations really work. So this list goes up to beyond 200 degrees. At the end of this list, between 160 and 200, we see a split in technologies. So there are different ways to supply those high temperatures. It could either be a closed-loop heat pump, where we are in the stage of the early prototype, or it could be a combination of a heat pump and a steam compressor. And the steam compressors are already quite established, with also higher TRL level and many products available. If you want to know more about the heat pumps that are already available at the market, I can strongly recommend the website of an IEA project that's called Annex 58. It focuses on high temperature heat pumps, so heat pumps supplying more than 100 degrees C. And on this website, you find a list of suppliers, you find a list of demonstration cases, lots of information on the technology used, on the technology readiness level, on the refrigerant, the temperatures. So all the information that is needed to get a good overview on the technology. And as an illustration of the variety that's already available, I've selected this illustration. It shows on the x-axis the heating capacity of the heat pumps, and on the y-axis the maximum supply temperature, and all the dots then for different suppliers. So this is one result of Annex 58. And for today, I want to point out 3 regions in this diagram, and I will, there's the laser pointer. That's great. So here on top, with the very high supply temperatures, we find steam compression systems and also Stirling systems. In the region with the high heating capacities, that is that one here, we find turbo compressors and products from Siemens, MAN, or Turboden. And in that region here, coming from the field of refrigeration and heat pumps, we find all the big names that we already know from refrigeration and heat pump technologies that are now expanding their product range towards higher temperatures. So there's a lot of information to be found on this NX58 website to get an update on the technology. Coming now to the barriers and opportunities concerning heat pumps, I want to start with a technical speciality of the heat pumps. It's a challenge, it might be a barrier, and it's the fact that the heat pump needs a heat source and a heat sink. So whenever we think of integrating heat pumps in an industrial process, we have to consider more than just the energy demand or the heat demand that we want to cover with that heat pump. We always have to look for a heat source where we can recover heat from, or where we can bring heat into this process in addition to the electricity that we need to run the compressor. So this is an important difference compared to a traditional gas boiler that only needs the gas supply and the process that is supplied with the heat. And the integration of the heat pump is also decisive for the efficiency. So sometimes it's not easy to see at first glance what is the most suitable integration point for a heat pump. So this requires engineering knowledge, process knowledge. So basically said, we need skills here. We need skilled people that can integrate and deploy all these heat pumps in industry that will be needed in the future. And this is now also addressed by a new action plan that the EU has launched, the Heat Pump Action Plan. It does not only cover industrial heat pumps, but also residential ones. But skills is an important topic in this plan. Another barrier that we discuss frequently when it comes to industrial heat pumps is an economic barrier. Basically, we see a price difference between electricity and gas prices, and this is also what is illustrated in this landscape here. So it's the ratio of electricity and gas prices, and if the country is green, the ratio is 1, and the more the country turns red, the electricity is more expensive than natural gas. And this ratio of electricity and natural gas can be used as a first indicator whether it's possible to save operating costs with a heat pump. If the COP is higher than this ratio, we can save operating costs. And this is very recent data. I took it from Eurostat. It's the first half of this year. And we see two different situations here. On the left, it's an example for medium-sized production sites. For example, what we find in the food industry. So it corresponds to the consumption bands IE and I3. And yeah, we see green countries in Scandinavia and Portugal. And on the right, there is the situation for larger production sites. For example, paper mills that we find all over Europe. And there, the ratio consumption bands are IG and I4. And when we compare these two landscapes, we find more yellow and orange countries for the large production sites. So this is an indicator that their heat pumps are more economic than for the medium size sites. So this is for the economic barrier. I think this is a very important aspect. And I want to put this now in a bit of a broader perspective. So when we discuss decarbonisation, if we really want to achieve low CO2 emissions, we have different options to do that. It could either be a heat pump, but there are also other technologies that we can use for process heat supply. In this example, I have selected steam production up to 12 bar. And the different options that we have are the heat pumps. It's the use of biogas in an existing boiler. It's the use of an electric boiler or the use of electricity to produce hydrogen in an electrolyzer and then use it in a hydrogen boiler. On the left, there's the comparison in terms of energy. So the situation with the gas boiler has the energy input factor of 1. And if we use biogas, we still need the same amount of energy, but coming from a renewable source. Similar situation for the electric boiler. There we use electricity, and for the longer conversion chain using electrolysis and a hydrogen boiler, we need more input here. What we also see here in this illustration is that the heat pump basically has two energy inputs. It's electricity that we use for the compressor, and it's the waste heat that is recovered with the heat pump. So the heat pump is an option to increase efficiency of the processes. On the right, we have the same situation, but here in terms of costs. So it's an extension of the landscape that we've seen before, using the electricity to gas price ratio of 3 to 4, as we've seen in the different countries before. Of course, the heat pump will then be more expensive to be operated than a natural gas boiler. But if we compare it to the other renewable options, the heat pump is still very attractive because we consume less electricity when using a heat pump. And with these two pictures, I'm already at the end of my presentation, and I want to summarize the points that I think are most important. Heat pumps are a very interesting and also future-proof technology for process heat supply because they allow for the reduction of CO2 emissions and increase in energy efficiency. With a heat pump, we can electrify process heat supply, and we can recover waste heat, which is already available at the site. Of course, integration is decisive to get to an efficient solution, and it's also a very dynamic environment. So there's lots of ongoing development. We will see more and more manufacturers and products entering the market, higher temperatures, steam generation. So this is definitely a technology which will be widespread in the future. Thank you.
Thanks a lot, Veronica, for giving us the European perspective. I think that this lays the basis for the next speakers that are going to follow. And because today we're going to hear the perspectives of different EU countries on industrial heat pumps and what is going on in terms of incentives, but also in terms of the challenges in different EU countries. And the first one is France. We are going to hear the French case from Yann Quiquenpoix from Daikin France. Yann has been working for Daikin France for the last 7 years on industrial heat pump chillers, but he has 36 years of experience in applied and refrigeration business. And he has been senior sales engineer at Mayekawa and regional director at GEA and also at Lennox. And of course, many other experiences that are not fitting today in this very short time that we have. But Yann, if you want to complete your bio, please do. And of course, the floor is yours.
Okay, thank you very much, Sandra. Good morning, everyone. I will take the control on the presentation, I suppose is possible. Yes, perfect. Very good. Okay, so to starting today, I really want to give you some feedback concerning the French market perspective, especially towards the industrial heat pump. And of course, with a short time, it's very difficult to speak about a lot of topics we can raise today. But the first thing, it will be to have some details concerning drivers and barrier as an introduction. The second point, it will be what we mean by decarbonization and what is the context in French territory, especially for heat pump. Another point concerning the focus for the fond chaleur, I will explain to you what means this fond chaleur. To be avoid to be too technical matter, but it's important also to understand what does heat pump means and what is opportunity also for the French market. The remaining barriers we also have concerning this kind of product. And to finish, I will just share with you a concrete example of decarbonizations that we already achieve, and it could be some example comments for future example on the comment is going. For starting point concerning the heat pump, one thing is really, really important as the main driver for the heat pump in the French market. This is what we call the 87% free carbon electricity in France. This is really, really important because this is a very good asset to promote the heat pump for heating system. Another point is concerned also the strong desire of the French government to promote the reindustrialization of the France, and as mentioned here, but also this is very focused on the decarbonizations, especially where the heat pump could be considered as also the good asset. For that, the French territory has dedicated agencies called ADEME and also some goals, especially for the France 2030. when they implement 1.5 billion euro to sustain the key project, especially for decarbonizations. For sure, to achieve this kind of decarbonization, we need to take care about energy monitoring and audit, and also the government want to sustain by some project the capability and the possibility to make a correct audit on the different plants to be sure to use the correct point. Another point is really also important concerning the heat pump market. This is what we call the RSE and the CSR policy, because most of the time in France, you will see, I will have some topic for that, concerning the possibility to recruit some good skills and the good candidate for the future collaborator, really for interest and focus on the RSE policy on the company. And this is what we, more and more, we can consider the made in France is really important. The second page is concerned the barrier, because of course, I already mentioned, one of the main barriers to promote this kind of technology came from the skills requirement, especially for maintenance and installations. Because even if we can to promote the very good solutions, we need to take care this solution is implemented for long-term meanings. For that, we need to really have the specialists. And for the moment, we have a lack of the specialists in the French market. This is a fact, and we also need to push to promote this kind of heat pump solutions to the government to take care about the new training for the new persons. Another barrier came from the F-gas regulation, of course, except the natural gas, and this is one of the opportunity. But for the moment, we also need to take care about the reality of the market and the reality on the demand, and many demands for demand are still continuing to use HFC. And HFC concern the direct emissions, not the indirect emissions, and sometimes natural gas cannot reach the same efficiencies than the natural gas, or with more complex system. Concerning the incentive, also, we have some issue to also improvement, and because for the moment, when we consider, for example, the cooling process only, and with the chillers, plus heat recovery, this is more or less looks like a heat pump, but we cannot support by the subsidy. Therefore, you receive less money for the system more efficient. I will return back on this point later. And also already mentioned by the previous presenter, this is a matter of the energy costs and energy costs, of course, and we have a very strong lobby from the gas supplier in France, and especially because you have a very big company. And also the reason that in European, this is a link between the gas, the cost of the price and the electricity, especially at this moment, this is one of the topics pushed by the French government. And this one is also important. The inflation is also important because they have directly an impact on the industrial investments. Okay, concerning the next topic is regarding the decarbonization. I don't read everything, and this is most important. The last 8th of November, our economical minister and Mr. Bruno Le Maire, announced a very strong engagement by the 15 clear decisions to push the decarbonization in France. And concerning the heat pump, 2 decisions are very important. The first and the decision number 6 to supporting the green technology, and especially for the topics called the green industry. The main decision is concerned how to compete the fossil energy by other systems like solar panel and so wind turbine and so on, but also heat pump and carbon-free hydrogen. For this solution, the decision was to implement the tax incentive, and the tax incentive system called the 3EV, and it is in French, it means Crédit Impôt Investissement Industrie Verte. For this one, the most important topic is concerned to reduce and to support the capex for productions and to support the investment from 20 to 45% with a budget of €500 million. Concerning the decision 7, this is how to put industry in front on the 4th position on the greenhouse gas emissions, because we have a plan in France called SNBC. SNBC means Stratégie Nationale, Stratégie Low Carbon. This is what we expect for 2030, 25% reduction and to 81% on the 50. For this one, the most important thing is to put some subsidy, and it is 5.6 billion a year for the major plant, and also 2 to 3 million euros, sorry, for the small company. This is also an important topic to sustain the heat pump in industry. Concerning the decarbonization, if we go on trends in a little bit on the details, we also need to consider how the energy consumption in industry, what is the value of the quantity of the energy, and is very huge in France, and because they're representing the 471 terawatt, and where more or less the half part are used only for heating needs. And also we can also consider the electricity need. On this place, we have the heat pump for sure, mainly cover the heating needs below 150%. I will mention this is what we separate, and you are there the scale concerning the different temperature category, the different needs, but most of the time the heat pump is used below 160%. Even if we have some information on some system could be reach higher temperature, this is also important to be concentrated where we have the very big important perspective to improvement. Concerning the next point, this is what we call the fond chaleur. The fond chaleur in France, this is also the same system used and implemented in France as a driver to sustain the big project linked with the waste heat recovery. And for this one, we can receive a 30% support and subsidy. And also when we have the project, when we can cover energy renewable, and for that, we can increase the support of this fund. This fund is mainly focused on the three topics, and efficiency, and also how to replace, to recover the energy, and also what is the energy renewable. But the most important thing is focused on the waste energy, and also is sustain the project where we can share this energy recover directly on site or on the nearest borough on the site, just to be sure to avoid and to reduce the waste heat. This is also important because to achieve this kind of system, the heat pump has some added value. Concerning the next topics, I don't be there just to make a training for the heat pump, but what is also important in France is to consider. Sometimes when we spoke about heating, we spoke about only heating production. But at the end, if we consider the chiller with the heat recovery, the heat pump, and the thermofrigo pump, at the end, this is exactly the same machine. The same machine using what we call the energy transfer by using the carbon-free electricity. And like that, we can put some energy from one level to another level, and like that we can count for the heat pump, and especially for heating consumptions, to reach 9.2 terawatt. This is mentioned by the kind of study in France. This is what we need to be concentrated on the which kind of benefits we can reach with this kind of technology. If we go a little bit more on the detail, this looks like more similar to the previous presenter. We can analyze what is happening, or it is a need on the French in matter of the opportunity based on the temperature. Of course, we have the cooling. In this case, we are concentrated on the heat recovery. This one is already covered by some system. And also we need to consider what is on the hot water, and for that we can continue to use air-cooled system heat pump, and we can start to use the geothermal probe, especially in the surface. For the temperature higher, like more than 80 degrees, and could be 19, we can use a kind of different, more complex system with a cascade, air to water, with water to water, and so on. But for that, we need to consider that the capex and also the opex will be a little bit more important. This is the reason that we really need to have the support of the government, because when we consider the deep geothermal energy of the fatal heat, the system becomes more complex. And if you want to produce the steam, the capex is increasing also a lot. This is the reason that for the moment, it's also important to consider the different technology. Mature technology is already existing, immediately suitable. And for the moment, this is more or less some cases we can find on the market, especially. This is the right direction for sure. But for the moment, we also need to I repeat again, this is also a matter of the skills. Concerning the barrier, another example, this is very strange because in France we have won some incentive by the Minister of the Ecological Transitions. This is the name of the heat recovery system. The purpose of these tools is just when you are recover the energy, you receive the subsidy. But this is very strange because if you consider the system like the cooling system plus the heat recovery, you receive the money. But if you consider the heat pump, you don't receive the money. This is one of the barriers we need to cross because at the end, this is exactly the same system. Or worse, this is more you spend the energy, more you receive the money. This is totally opposite what we want to achieve. If you go a little bit on the details, just for your information, this is just we call on just is really important because for any kind of thermodynamic system, we are using the same diagram. This diagram is an enthalpy diagram, meaning what is the relation between the energy consumptions and the energy transfer. For this one, we have on this part the cooling the system, and this one we have the heat recovery. The most important thing to understand, if we consider to have some tools using only the capacity, the absorbed powers. In this case, you can see even you increase the temperature, of course, you increase the capacity in matter of enthalpy, you increase the capacity of heating, but at the end, you increase also the energy spent to run the system. In this case, if you make a very simple comparison, you can see, okay, I increase the capacity, but if I increase on the same time the absorbed power, finally I'm reducing the COP and finally the efficiency of the system. And for promote the heat pump, it will be interesting to change this kind of incentive system and to consider a global COP. Global COP means for the same energy consumptions, you can produce cooling, heating and cooling. And therefore, finally, your global COP is much, much, much better to prove or to sustain the energy saving. This is what I want, because sometimes if you consider only one part of the system, finally you can create a kind of hole or of a misunderstanding of the system. If you consider a global system, finally you are really focused on energy efficiency. Okay, just to continue, another barrier is also concerned the F-gas. As you know, we have some reduction at this moment, and on the green part, this is what we expected on the 2014. And now the new proposal for 2022 is to a little bit more speed up to reach the F-gas. But the problem, if you consider only the orange curve, you can see even with you can just only cover the maintenance system. But the problem, if you want to consider what is the reality, and in the meantime, we will continue to use some F-gas on some other solutions, we cannot sustain the system. And another point also concerning the F-gas, this is also important to consider, if you want to move toward another type of gas refrigerant, you also need to consider what is the inflammability of the system and also the toxicity of the system. This one means you need to train the people. This is achievable, but you need to really to train the people to sustain the possibility to have the market. To finish my presentations, I want also to share a concrete example of decarbonation. Decarbonation, it will be, we achieved last year a project to replace the gas boiler for 2 times 62 kilowatt. For that, we analyze what is the needs during the years, and we replaced by the heat pump with a very standard production just to heat the workshop and on the factories. And for that, we analyze what is the needs during according to the external temperature. And based on this one, we define a profile for the heat pump. And at the end, we save more or less the 63% of the reduction, the gas emissions and the reduction energy saving. And this one is converted also on the CO2 wind, representing 55 tons of equivalent CO2, meaning it is more or less, this is what tools we are using, we save like that 267 trees. And this is what sometimes we present to the customer. Another point is also important. I cannot share today because the project is just starting this year. We are more or less 10 times more using the system, but we save more or less more closely to the 5,000 gigawatt-hour saved by the replacement on the gas boiler by the heat pump on industrial applications. To conclude my speech, this is really, really important. And if we want to consider the French market and the barrier and so on, of course, and we are different step and where the heat pump needs to be included. For that, we really need to be sure that with a consulting partner, we need to be sure that everything is understood according to the heat pump market. Concerning the partner for operational matter, for sure, the many installer and also the manufacturer and so on are fully aware and have also the problem, but for that they need to consider the lack of the human resource and the training needs. And concerning the incentive, we also need to continue to promote the thermodynamic technology. This is my final words. This is beyond the heat pump. You need to speak more on thermodynamic technology to compete the fossil energy. Thank you very much for your intentions.
Thanks a lot, Jan, for this very complete presentation on the French case, and also for highlighting not only the barriers, but also the opportunities that the French government and market give to who wants to install an industrial heat pumps in their plant. And it was very interesting also the last example case that you showed and it shows that 63% of energy saved is really a lot of energy. Now we are going to hear about the Dutch case from Jonathan Vandenberg, and he's gonna give us a presentation on heat pumps in the SDE++. Let's see what this means. A premium subsidy scheme for the Dutch energy transition. But before a few words about Jonathan, he is a sustainable energy researcher at the Dutch Environmental Assessment Agency. And after obtaining a master's degree and PhD in nuclear fusion, he turned his career towards policy advice. He's currently working on the electrification options in the SDE++ subsidy scheme, and this includes various applications of industrial heat pumps. So let's hear this, Jonathan. The floor is yours.
Yes, hello, and thank you very much for the introduction, and thank you also for inviting me to this webinar. Yeah, I hope to give you a little bit of an hands-on presentation on the work that we are doing in the Netherlands, for creating opportunities for heat pumps. And this we are doing with the SDE++. That's a premium subsidy scheme for the Dutch energy transition, and mainly discussing the heat pump case today. As Veronica has already told you, the electricity in the Netherlands is quite expensive relative to other countries. On the map, the Netherlands was red. And that means that there is a barrier for heat pumps in the Netherlands. And with subsidy, it might be able to cover the barrier. So what will I be telling you today? Now, firstly, give you a brief introduction to the SDE++. Then discuss a bit more about the categories that we have for heat pumps. Why does that work and what are the limitations for that? And also, finally, I would like to introduce you a little bit to the work that we are currently doing on a new category for system integrated heat pumps in evaporation systems. So that could cover also mechanical vapor recompression systems on the high temperature level. Okay, the SDE++, that stands in Dutch for the stimulation of sustainable energy production and climate transition. And it is a Dutch ministerial ruling that has been in force since 2008. And it's an exploitation subsidy, so a premium subsidy scheme for the unprofitable component of exploitation. And it includes many different categories. In total, in the last round of this subsidy, there were 183 categories to choose from. So something for everybody in the energy transition, I would like to say, and there are even more to come. Yeah, so what kind of technologies does this subsidy cover? Well, we have renewable electricity, renewable heat, renewable gas, low carbon heat. That will be the one that we will be discussing because it covers also the industrial heat pumps, and also low carbon production, for example, carbon storage and utilization. Okay, so how does this subsidy work? Well, we want to cover the unprofitable component. So in the end, the subsidy that is provided is given by an application amount that is determined at the moment of application, minus an annual correction amount. And this correction amount includes the market profits for the produced goods. And also it includes the ETS advantages that a company might have when they move to a sustainable technology. They might save on ETS costs. And so this subsidy is a subsidy on top of the ETS system to accelerate the transition, basically. Yeah, how does that look like in practice? Well, here we see an example of an SDE contribution with the duration of 15 years. The blue line is the application amount, and that is fixed at the beginning. And the red line, that is the correction amount, which is determined yearly, and that can vary with market prices. And the difference between them is then the subsidy. That's covered over the years. However, the subsidy is limited by a few factors. And well, firstly, we have here the base price. That is basically a risk, a limitation to the government risk. If the market price becomes too low, then the government will not cover all the differences anymore. Yeah. And also on the high side, the application amount is limited by the base rate. And the base rate, that is a rate that is calculated for each technology yearly. And that's also where our work at the Environmental Assessment Agency, the PBL, comes in. Because we are an independent assessment agency and we give a yearly advice to the Ministry of Economic Affairs what base rates they should use and what would be the maximum subsidy that can be provided. And yeah, this is an important aspect of the subsidy because you want to have a subsidy that is effective and also efficient. It should be effective because if the subsidy is too low, if the base rate is too low, then companies will simply not find it attractive to do this. They will not cover their costs, and nobody will do anything. But if the base rate is too high, then it will be very attractive to do the subsidy, and yeah, the subsidy will not be efficient because we are basically wasting government money. So that is the goal for us at the PBL, to look at all these technologies and determine the exactly adequate base rates for each of the technologies. And for that we use the methodology of the levelized cost of energy. And yeah, not all the technologies can be just simply included. A category in the SDE has to have a few ingredients. So there are a number of requirements. You need a defined technology, a measurable quantity of production, which can be tricky sometimes. You need a known production capacity. The costs of production must be known for us to make a good advice, of course. And also the resulting emission reduction is an important component, of course. And we make a yearly advice for that. And an important part of that is that we also have consultation with market parties and trade associations, just to listen every year what should be changed and what are the parties experiencing in troubles, and what can we do with that in the new subsidy round. Okay, now let's look at what this means for heat pumps. Indeed, there are quite a lot of heat pump categories already in the subsidy. And we have heat pumps which use a natural heat as a heat source, and also residual heat. And on the natural heat, we have aquathermal energy, greenhouse energy, geothermal energy, etc. But the technologies that I am working on mostly are the industrial heat pumps, which use residual heat. And also, we are now working on this new category, the system integrated heat pumps, which is still work in progress. Okay, so this industrial heat pump, how does this look like in the SDE++? Does this qualify? Let's take a look. Now here we see an schematic of an heat pump with the heat source, a closed system heat pump with the heat source being residual heat. In the evaporator, that heat is proceeding towards a compressor that uses electricity and then fed into a certain process. So yeah, this is quite a well-defined technology. As you have discussed, the TRL level for lower temperatures, it's like up to 90 is like TRL 11. So this works quite well. We know about it. Also, we can have a measurable quantity of production because the heat output is given by the delta T on the hot side times the mass flow on that hot side. That's things you can measure very easily and record. Well, the production capacity is also known if you assume that there's a continuous process in industry, then you can count with maybe 8,000 full load hours. The production cost is something that we can determine. We determine that from the applications from previous years. It gives us a very nice overview, and also from the consultation for the investment cost, the maintenance cost, and the electricity. And there we can use a average COP of 3.5. Well, the reference situation was that there was heat from a CHP or gas boiler, so that is also well known. And with this COP of 3.5, you might, if you look at your own case, you might see, well, that's not exactly the same. And yes, that's also one of the limitations. We make this subsidy, we try to make it fit for most of the projects, but not all of the projects. And with heat pumps, we know that there is actually quite a large variation in investment costs. Depending on the temperature, a heat pump might be the temperature gap, and a large temperature gap might be a more expensive heat pump, or also the integration costs might vary. There's also variation in full load hours. For example, companies that are running 5 days a week or only part of the year. We are discussing only the industrial heat pumps here, so no heating systems for residential heating or something. But we found that if a certain company has a small amount of full load hours, that their exploitation is not fully covered because they can only receive subsidy for a smaller number of hours. Therefore, we had to add an extra category for 3,000 full load hours. Also, there's a variation in the COP, depending on the temperature gap. And when you have a very small COP, you need a lot of electricity, so your exploitation might not be fully covered with this subsidy. But if you have a very large COP, very high COP, yeah, then you might not even need any subsidy. So we have also made a limitation for COP below 10. Okay, so finally, let's look at this. This works. There are limitations, but every year we have applications. But what about heat pumps in system integration? And then especially we are considering heat pumps in evaporation systems. So that might include evaporation systems in food industry or chemical industry, or also paper mills. Steam rolling systems. And this is a different type of heat pump. It's an open system where there is a evaporation process and it requires heat in the form of steam. Then this evaporation heat, the process heat, exits as latent heat. And in the previous situation, it has often been used for like a multi-stage evaporation system, or it's high-value heat. But what can you still do? You can reuse this heat with a compressor and put it back into the process. That is the technology that is described as mechanical vapor recompression. And that's a very nice situation, because it's energy efficient. The temperature gap is quite small, and the COP is very large. So, okay, you think that this might not need, according to our requirements, this system might not need any subsidy. But nevertheless, we have received a lot of complaints or feedback from market companies that this does not work. And even there was a parliamentary resolution in the Netherlands that was passed that said that there should be a better subsidy scheme for these types of systems. So what is the problem here? Well, the problem is that in our previous category, we had accounted that the heat source of the heat pump was waste heat that had no value. But this heat source actually is quite valuable. It's a high temperature heat. So we have to do something about it, and we try to get on with this and try to make a new category. So how does that then work? Now, we have again the requirements. Is this a defined technology? It's okay. It's a heat pump in an evaporation process. There are quite a lot of different technologies that can apply for this, steam rolls or evaporation systems in food industry. But we say, okay, that's fine. That's okay. Now, what's the old situation? The reference case is that was steam used, and but okay, that's a little bit difficult actually. But what is the measurable quantity of production? This was quite a challenge for us to do that, because you would like to normally use the heat output of the heat pump as a quantity of production, but that simply is not well enough for these high temperature heat pumps. And I think also that the previous speaker commented a little bit on this. Because you should not only consider the output, but also what this heat pump does to this other heat stream. It also takes away high value heat. So we decided that the only way to go with this is that the quantity of production is actually the reduction of fossil heat demand of the total system. Okay. The production capacity is the same as for the other systems, and also the production costs, we have a similar approach. And we actually come to the same COP for these types of systems as for the normal heat pumps. Why is that? Now, that's because I have to skip a few things here. Because the reduction of fossil heat demand is actually technically a very similar approach to a normal COP. So we have actually the heat reduction coefficient that's given by the expected reduction of fossil heat demand divided by the electric power. And you might recognize this from a normal COP of a heat pump, the thermal output divided by the electric power. And that is technically maybe the same, but there is one important difference. That is that the thermal output, that for the Ministry of Economic Affairs, there's a quite important difference. For them, the thermal output counts like production. They want to support production in a renewable way. But when we look at a reduction of fossil heat demand, that is more like an efficiency measure, and it's a little bit difficult for the ministry to consider that in the same way. Although technically you can say it's the same. So we are now still discussing this with the ministry, and we are working on our advice. Hopefully this will become a new category, but we are not sure yet about that. And that are some of the challenges. So that brings me also to the takeaways here. The SDE subsidy aims to kickstart the energy transition with some subsidies. But if we add new components, as we add more categories, it becomes even more difficult to add those. There are more complications, And they are not only technical complications, how should we calculate this, but also sometimes political complications. What does this mean for the political system? So yeah, that's what we are working on. We are making some progress, but there's also still a lot of potential to unlock. So yeah, thank you for your attention. Looking forward to some discussion maybe. Yeah.
Thanks a lot, Jonathan, for this very interesting presentation on this subsidy. I hope that among the audience there are some industrial heat pump manufacturers or end users that are from Netherlands that could take advantage of this subsidy, and we would be very happy to put you in contact with them. And a reminder for those who have joined later, you can put your questions in the chat, and please also put the name of the speaker you're addressing so that they know who to answer, who needs to answer. Thanks a lot. And let's move to our next speaker of today. Let's fly to Denmark with Fabian Bühler, who is advisor for energy efficiency in the industry at the Center for Global Cooperation of the Danish Energy Agency. The focus of his work is to advise international governmental partners on policies and regulations, as well as developing capacity building programs to drive energy efficiency, electrification, and use of excess heat in industry. Fabian has an experience with industrial energy efficiency and district heating systems from engineering consultancies and research, and he holds a master's degree in sustainable energy and a PhD in thermal energy from the Technical University of Denmark. Today, he's going to give us a presentation on policy learning and experiences on industrial decarbonization. So please, Fabian, the floor is yours.
Yes, thank you very much, Sonia. Thank you very much for the kind introduction and for giving me the opportunity to speak here today. As Sonia said, we'll be presenting to you some policy learnings and experiences from Denmark, which focus on industrial decarbonization. Not only on heat pumps, but as you will see, heat pumps play a very important role in the Danish green transition of the industrial sector. During my presentation today, I will give you a short introduction to the role of the Danish Energy Agency, give you some background on the Danish experiences with industrial decarbonization, and then I present you the framework for industrial decarbonization we have currently in place in Denmark, which includes strategies and agreements, stakeholder dialogue, and the policy and regulatory elements. To start with, to give you a very brief introduction to the Danish Energy Agency, we are an agency, a government agency under the Ministry of Climate, Energy and Utilities. And we are in charge of the green transition of the Danish energy system. We work with all aspects of the Danish energy system. We were recently restructured to represent the new challenges which are coming in the green transition in Denmark. And that's, for example, that a Center for Electrification was created, which includes, for example, a green industry transition team, and also for electric transport. We have a team for green utilities, which looks at power plants and how they can be converted to biomass and biogas, but also taking care of all the wind power being built in the North Sea, Baltic Sea at the moment. I'm located at the Center for Global Cooperation, where we have government-to-government collaborations with 22 countries around the world, where we advise on the Danish green transition. I show here the partner countries we collaborate at the Danish Energy Agency with, and we focus on 4 main areas in our consultancy with the foreign governments. One is on energy system modeling, one is on flexible power plants, one is on energy efficiency, and then lastly, district heating. On energy efficiency, we focus on collaborating on the energy efficiency in buildings and industry, but in many countries, we moved away from energy efficiency consulting to decarbonization consulting. And with our government-to-government collaborations, focus is always on policy and regulatory frameworks. In some of the countries, for example, in Mexico and Vietnam, it's also technical assistance where we work with local industries to implement energy management systems or establish energy auditor systems in these countries. All the motivation for the work we do nationally in Denmark and internationally is the vision of reaching a climate neutral society. In Denmark, we have the Climate Act, which is the law that Denmark should reduce greenhouse gas emissions by 70% by 2030 and be climate neutral by 2050. That's in the law. But there are also political ambitions and goals which change over time, and they tend to become more and more ambitious. So the latest government, which took office at the end of last year, wanted to be more efficient and more ambitious than the previous government and moved all the targets ahead. So climate neutrality already by 2045 and being climate negative by 2050. There's also the political goal of becoming, have 100% green electricity by 2030, which is, of course, a very important aspect in electrifying and decarbonization industries through heat pumps. Also a goal which is not written here, it's that also all gas consumption in Denmark should be 100% green by 2030, which is achieved through more production of biogas and reducing natural gas or gas consumption overall. Yes, so much to the introduction to the Danish Energy Agency. I would like to give you some experiences we have in the industry sector. And I think one good case is the Danish dairy industry sector, which accounts for a lot of the energy use in the Danish industry, but it's also a very economic important sector in Denmark. Here, what I show you is that the Danish dairy industry energy consumption by fuel type over the last 50 years, where you can see that in the 60s and 70s, Danish dairies in the dairy processing used a lot of fuel oil for thermal energy use. Due to the energy crisis in the 60s and 70s, shift was in Denmark to move away from fuel oil to, for example, natural gas to become more independent of fuel oil and to use natural gas from the North Sea, which also happened in the dairies, which converted from natural fuel oil to natural gas throughout the 70s, 80s, and 90s. And today we are in a situation where all the thermal energy demand is covered by primarily natural gas and an increasing share of biofuel and biogas in the last 5 to 10 years. What you can also see is that heat pumps here indicated in red, they have been there a little bit all the time, but also in the last recent years, the share of heat pumps increased slightly, but here we expect a higher increase. What you will also note is that electricity consumption has increased quite a lot after 2010, and that's not because dairy industry uses more electricity, but more because many dairies decided to shut down their combined heat and power production, and thereby they buy more electricity on the market, which goes into this statistic. But the overall message is that a big shift was already possible to move away from fuel oil to natural gas. And we hope to see the same shift now away from natural gas to electricity and biogas and biofuels. Here I show you on the left the energy intensity of the Danish dairy industry since the year 2000, and on the right, on the left, greenhouse gas intensity of the Danish dairy industry, and on the right of the energy intensity of the dairy industry. And you can see that since 2000, the last 20 years, the greenhouse gas intensity of the dairy industry has declined continuously, while the energy intensity declined, but in the recent years, the rate decelerated and it's almost constant. And that's because in the Danish dairy industry, a lot of energy efficiency efforts were made in the beginning of the 2000s due to several energy efficiency obligation schemes and voluntary agreement schemes in place, which supported energy efficiency, which reduced energy consumption. Energy intensity continued to decrease because we have decarbonized the overall energy system, meaning electricity has become greener, and thereby greenhouse gas emissions scope 2 in the dairy industry have continued decreasing. Overall, since the 1970s, energy use in the Danish food industry was reduced by 32%, while production value increased by more than 60%. And here in the food industry, we have not seen any structural changes, unlike in the overall industry, where a lot of the steel industry has moved abroad from Denmark. In the future, the aim is to continue the work on energy efficiency, but focus more on the shift towards electricity. And I saw a question, Krona, KR, is an abbreviation for Danish krona, the valuta, the currency in Denmark. And that's the production value generated by the Danish dairy industry. Yes. Moving towards the energy policies in Denmark and the key elements of driving the green transition. We have three key elements that have supported the evolution of Danish energy policies over time, and they resulted in a very stable framework with some degree of flexibility. For once, there are cost-effective subsidy schemes which are evaluated on a regular basis to avoid over-subsidizing. Then we have energy taxes on fossil fuel, which make renewable energy more competitive and incentivize energy efficiency. And the revenues of these taxes are also used for research and development support. There is a dialogue with stakeholders to ensure ambitious and realistic targets, as well as making sure that all the regulations are well functioning and efficient. So in short, what we have in Denmark is a combination of an effective state and the market. And I will introduce you for the three circles some examples on what we do in Denmark. So long-term energy strategies and agreements, it's quite important aspects. In Denmark, we have three major political agreements which dictate how we work with energy and climate targets. And they all also impact the industry in their green transition. So for example, the Danish Energy Agreement from 2018, it defined that the electricity tax for electricity used for heating should be reduced. And it also implied that the excess heat tax applicable in Denmark should be revised. In addition, the Danish Energy Agreement also allocated substantial subsidy funds for energy-saving initiatives in industry. In the green tax reform from 2020 and revised in 2022, an increase of taxes for fossil fuels was made public, as well as the implementation of a CO2 equivalent tax from 2025. And also in the green tax reform, additional subsidy funds for the industry were allocated, and it was also made mandatory, or it will be made mandatory but specified in the green tax reforms, that industry should do mandatory climate audits. I will come back to that in a moment. And lastly, the climate agreement for energy and industry from 2020 allocated even more money for the green transition in industry in the form of subsidies, but also required the Danish Energy Agency to perform an analysis of the industry and see how the industry become greener and where there are potentials and barriers for the phase out of fossil fuels. And here the focus was on high temperature processes, where we see the major challenges in the green transition. Yeah. And it's also like as part of the strategy, clearly defined how the green transition should happen. And this should happen through energy efficiency, use of other renewable fuels such as biogas and electrifications to reach climate neutrality by 2045. And here it's also clearly distinguished between direct electrification, which is the use of renewable energy in, for example, heat pumps, to indirect electrification, which is the use of renewable energy to produce hydrogen. In one of the analyses performed in Denmark, it was clearly shown that direct electrification can contribute significantly to the decarbonization of the industry sector, but also district heating, transport, and households. Here you can see the CO2 equivalent emissions in industry and how they can be abated through direct and indirect electrification, and the share of emissions not convertible to electricity. And we can see industry can, to a high degree, be directly electrified, and that's also due to the high share of low temperature process heating in the industrial energy use in Denmark. As mentioned before, food and beverage processing has a high share of the total energy use in industry. There's a small share of non-convertible emissions, and that's from, for example, cement production, process-related emissions, or high-temperature processes, which cannot be converted directly to hydrogen. Another element is the role of green gas in industry. And here it's also very specified where green gas should be used in the future. The aim is to phase out natural gas by 2030, and that's only possible through a reduction of gas demand and an increasing a share of production of biogas in Denmark. And here there's also if you want a merit order that process heat for low temperature should reduce gas consumption continuously over the next 10 years. While we see that process heat at a high temperature will actually increase their consumption due to the phase out of coal and pet coke in the coming years. And there we don't see a strong reduction in gas use. Yes, I will just go very briefly into dialogue with stakeholders. In Denmark, we have established climate partnerships between the government and industry. There are 14 public-private climate partnerships, and they also include manufacturing activities. There's one for energy-intensive industry and food and agriculture. And the aim of these climate partnerships is that industry shows the way forward and gives concrete recommendations to the government on how they can obtain climate neutrality by 2045. And they come up with a roadmap. Here's an example of the energy-intensive industry partnership, where they roadmap how they can reduce their emissions by 70% until 2030 with the baseline of 1990. And they divide all these options, for example, energy efficiency, shift of products, electrification, into technologies which are economic feasible for them today, some which will be in the future, and where there is government support required. And through this engagement with industry, we make sure that all the upcoming policies are in line with the requirements at the industry to perform the green transition. Lastly, I will touch on the subsidy schemes and what we are doing in Denmark with regards to that. That's primarily anchored here at the Danish Energy Agency. One important aspect that there's not only one instrument, not one setup which can drive the change we want to see, but it's important to have many different elements. And I can show you why and give you some examples. And here we can imagine that the distribution is of high temperature heat pumps, for example, for industrial processes. There are different technologies, some with a very high carbon intensity, which would be a natural gas boiler or petcoke boiler, and some low carbon intensity technologies such as heat pumps operating on renewable electricity. And to drive this process heat supply to this low carbon intensity technologies, we have different elements to shape this curve. We can have standard and bands on the high carbon intensity technologies. In Denmark, for example, we have a phase out of petroleum coke from 2025 onwards, which will ban combustion of these fuels in industry. We have taxes to make it more feasible for industries to use low carbon intensity technologies for process heating. And we have research and development support to make the low carbon intensity technologies more efficient, cheaper. And then we provide subsidies for the first industries to move towards these technologies, to create a market for these technologies and create acceptance for industry. The elements we work with are energy and CO2 taxes, voluntary agreements. There are subsidies for investments into low carbon technologies for industry. On an EU level, we have mandatory energy audits. There's EUDP in Denmark, which is a subsidy fund for energy research and development. And there are qualified energy consultant schemes, and we have the website sparenergi.dk, which provides access to information for households, but also for industries to find inspiration for energy efficiency and electrification, but also all information regarding subsidy schemes and taxation. Yeah, see, I'm running out of time. I will skip the text slide, but show you the current policy elements in Denmark. So, of course, we are in the European Union, and all our actions are mandated also by the Energy Efficiency Directive, where we have mandatory energy audits for large industries. But in addition, Denmark will introduce from 2025 climate audits for all enterprises which have to do energy audits. And the climate audits have to look at the emissions of the company. And there will be also a requirement for large industries to have certified energy management systems after ISO 50001. One important element is energy audits are very important in our opinion to create awareness of all the energy efficiency opportunities. However, you need other instruments to actually make industry implement these opportunities. And that's subsidies. We have a subsidy scheme for energy efficiency where industry can apply with getting up to 40% of the costs as a subsidy for their investment covered by the state. And we have a voluntary agreement scheme for excess heat utilization. If industry utilizes excess heat, for example, with a heat pump for district heating, they can get tax exemptions if they document that their processes related to the waste heat generation are in an optimal condition, energy efficiency-wise. And then we have the phase out of petroleum coke. Yes. So just a summary. The best practices we have in Denmark are based on the policies, but if we translate them into technical actions, we can see that energy efficiency still receives a lot of attention. We have conversion away from steam to hot water. Biogas production and utilization is very important, and a heat pump for process heating. Also district heat production based on industrial excess heat, it's something which is invested quite significantly in Denmark. Yes, thank you very much, and I'm sorry to be a bit over time.
No problem, Fabian. We've got time. No problem. Thanks a lot to you for this overview of the Danish energy policy and also the various instruments that are foreseen for energy efficiency. And I see that there are already some questions for you in the chat, so feel free to answer them while I introduce the next speakers, plural. We have Padraig O'Reilly and Seamus Owen from the Technical University of the Shannon. So I'm going to introduce them quickly. So Padraig is a mechanical engineer with a master's in project management. He's working in the building services engineering sector since 1994, and he was specialized in the areas of renewable heating systems since 2002, with a particular emphasis on the design and installation of heat pump systems. And in 2021, he was appointed as development manager for the Technological University of the Shannon. And then we have Seamus Owen. Seamus is a mechanical engineer with a master's in renewable energy and energy management from the University of Limerick and Ulster. He has 25 years of experience in energy, education, and flexible learning environments. His research interests are focused on sustainable development, sustainable energy, and climate action. And he is also chair of directors of the Tipperary Energy Agency and Secretary General of Federene, the European Federation of Agencies and Regions for Energy and the Environment. A lot of things here, so I will not steal too much of your time. Padraig, Seamus, the floor is yours. You can take control of the presentation.
So good morning, everyone, and thanks very much for the introduction. So we will give you a perspective from Ireland in the case of industrial heat pumps. And yeah, I suppose to maybe introduce, first of all, the Technological University of the Shannon. We're a new university formed 2 years ago following the merger of two institutes of technology. You can, for those of you that have ever traveled to Ireland, we span the Midwest and the Midlands region of Ireland. With 6 campuses across the entire region with over 15,000 students, approximately 2,000 staff. And we have extensive European networks and international networks, including we'll become president of the Regional Universities Network, European University, from January of next year. But sited within the Technological University is a research institute focused specifically on sustainable development, which I'm the principal investigator of. And this research institute brings together our expertise and focuses particularly on sustainable energy, climate action, and rural development, along with a range of other related topics. But obviously, in the context of today's presentation, we're focusing on work that has been done in the context of sustainable energy in particular. I suppose to paint the context in terms of industrial heat in Ireland, very important to say that I suppose Ireland is one of the lowest in terms of the penetration of renewable heat across Europe. While we have done significant work in increasing penetration of renewable electricity, so we had a large storm pass over Ireland a number of 2 days ago, and at points in time, approximately 80% of all our electricity was coming from wind during those couple of days, and the average is around 40 to 45%. Whereas in heat, it's it's in single-digit figures. So we have a huge amount of work to do in terms of renewable heat. And one of our particular challenges was a lack of data. So our National Energy Agency, SEAI, commissioned a national heat study 2 years ago. The link is available there on the slides, which I'm sure will be shared. And this was really our first comprehensive look at heating across all sectors, residential, commercial, public, and industrial sectors. So we had a distinct lack of data. So you can see that industrial heat accounts for about 33% of national demand and about 20% of our cooling demand. You'll see the relevant CO2 emissions there. And also very useful was the identification of the heat demands by temperature grade, which Veronica referred to as being really important kind of indicators in terms of the TRL availability of the technologies for penetration. And you can see we have about 40% of the industrial heat in Ireland is below 150 degrees. So again, generally open for commercially available technologies on the market. And I think it's also important to say in terms of industrial decarbonisation, which connects very much with Fabien's point, there has been very much a focus within industry on energy efficiency to date, and limited, if any, focus on renewable energy heating. And we have a national large industry energy network which shares best practice and collaborates to maximize impacts. And again, very much the focus on those has been on energy efficiency measures. But there's a very large focus now on a movement towards the overall decarbonisation agenda, driven by multiple, I suppose, political, economic and corporate factors also, given we were dealing with industrial bases. So I just went, oops, apologies. I suppose to maybe bring a different perspective to the other presentations where we had a focus on the global technology availability, the specifics in France and the Netherlands in Denmark. I'm maybe going to come from an economic perspective. So I was a member of the Shannon Estuary Economic Task Force, so a government task force set up to look at the economic development of a region in Ireland, which essentially covers the Midwest region. And for those, again, who have been in Ireland, the Shannon River flows through the region. And so that was the focus of the task force. And this region has a very large penetration of industry across multiple areas, and a significant portion of foreign direct investment within that region. So I chaired the onshore renewable energy group, and within our climate action plan in Ireland, there is a requirement for industry to reduce its CO2 emissions by 35%. So by 2030, so a significant challenge. So looking at opportunities for demand reduction. So what could we do from an economic perspective to support those industries? Clearly a focus on decarbonisation of heat and also increased penetration of renewables for electricity generation. And as part of this work, we commissioned a study to look at the decarbonisation of process heat, specifically using the experience from the national study, but focusing on working with companies and organisations in the region. And part of this study, I suppose, gave us insights to what the companies are thinking and the industries are thinking. And on this slide, you'll see some quotes from some of the directors of engineering in these companies. So many of you may be aware that Ireland has been very successful in attracting foreign direct investment companies. So again, in the region, we worked with local industries, but also with foreign direct investment companies. So large global companies that are looking at decarbonisation. And clearly, some of their strategies are set from abroad. So from the headquarters that may be in the US or other parts of Europe. And they have a clear decarbonisation agenda, but some of the decisions are being made outside of Ireland. But then we also worked with some of our Irish companies, their food and drinks industry. We also, again, have a very large dairy industry in Ireland. And they are trying to make plans 5 years ahead in terms of their decarbonisation. And they're starting to look then at available technologies. And clearly, heat pumps, mechanical vapor recompression technologies are available on the market. They are looking at them and considering them. Direct electrification, biomass systems, and heat recovery solutions. So those are all in the space that are looking at. When we compare ourselves to Denmark, for example, Fabien mentioned biogas as a core part of their solution. In Ireland, we have a completely underdeveloped biomethane and biogas industry. So while the technology is very viable, the sector is not there. And then I suppose discussions around green hydrogen emerging in the future. Part of the task force was a significant focus on floating offshore wind and developing complementary technologies in terms of hydrogen production, which may emerge as a solution into the future. Part of the study then was to look at a number of different scenarios. And again, in the national heat study and our regional study, we looked at a range of different scenarios. And I've just presented one here where looking at overall decarbonisation, and heat pumps was just one of the technology solutions that was considered. And again, looking at the heat profile, the temperature profiles across the sector, or the sectors in the region, what's possible and what might be appropriate. You can see on the base of the graphs here, heat pumps made some penetration, and MVR based on the profile and the data available to us from engagement with industry. And this was a rapid progress, so where we would move very quickly to put in place the solutions, the supports, the subsidies, and the policy measures that would drive the technology. But you can see that's matched with some direct electrification. We do have some technologies where direct electrification makes immediate sense, mixed with biomass, some penetration, large penetration of biomethane into the future, and then balancing off with small components of fossil fuels. I suppose a couple of the quick issues that arose from this discussion. Again, coming from the food industry in particular, a lot of the engineering and the plant managers in some of the sectors challenged to release capital investment in decarbonisation projects, given the scale of investment. And when we compare that to the FDI sectors, FDI are making investment decisions are based on global prices for investment and capital investment across all of the plants. So we do, these companies are presented with some challenges. I think the electricity price ratio disparity, if you noticed from Veronica's graph, Ireland was a big bright red colour in both of those scenarios that she presented. So it is a very big challenge to make a heat pump solution within the Irish context viable. And then I suppose the next two barriers are really related to available technologies and case studies in the Irish context and the knowledge and capacity base in Ireland. I think many of my previous speakers mentioned the skills and the knowledge, and the competency is significantly lacking, and that is a major issue in Ireland. Interestingly, opportunities to learn from some of our FDI companies who may have large knowledge bases but just outside of Ireland. How could we leverage some of that to upskill the people in Ireland? I think some of the opportunities and issues we need to consider, I think addressing that skills issue, we're looking at regional decarbonisation supports. So that one-stop shop approach where we can support industry in their decarbonisation pathways. We do have significant challenges in terms of grid import capacity challenges, where when companies are looking at large-scale heat pump installations that might require a grid connection, there are certainly, under the current regulations, significant costs. Whereas if we look at some measures to that, where it's a flexible, a non-firm grid connection, which would be suitable for heat pumps, that could remove one of the technical and financial barriers to heat pump deployment. And we have, I suppose, a lack of depth in both the incentives and supports. We have a lot of non-financial support, so technical advice from our National Energy Agency. There are some financial supports, but certainly the subsidies that are currently available are not sufficient to bridge the gap in terms of the overall investment costs for industry. So they're looking at other opportunities. So I'm going to pass over to Pádraig, who's going to maybe take you through some of the other work that we're doing here in Ireland in relation to heat pumps and heating.
Thanks, James. And good morning, everyone. It's a pleasure to speak to you this morning. I'll just take on the conversation there and focus on some of the research projects that we have carried out in the development unit, which is part of the Sustainable Development Research Institute in the Technological University of the Shannon. And in particular, I'm just showing there that we have a team of, in the region of 10 researchers. We have about 30 or 40 live projects, but our main areas are clean energy transition, climate action, rural development, and social enterprise. So some of the projects that are relevant to industrial heat pumps here start with our work that has gone back a number of years in the areas of energy efficiency. And if I just to name a couple of them here, we had a build up skills initiative 10 or 11 years ago, and now we're currently working on the 2030 version of that. So our projects tend to work in the higher TRL regions, and we have a very strong outreach part. So we bring policy out into industry, and then learn lessons by doing pilots and tests there, and then providing feedback to policymakers at national and EU level, which is very much what the build up skills process is all about. And as the years have gone by, we've moved from energy efficiency into low carbon and circular construction, and hence the current project there of BuzzGo Circular, which is we're in the middle of that project at the moment. But of great relevance then to this conversation is the Heat Pump for All project, which concluded earlier this year, and which in that project we looked at a mixture of residential and commercial, and even we had pilots in Austria, Ireland, and Spain, and one of the pilots in Austria actually had an industrial heat pump where heat recovery was used, where there was a factory-wide cooling system, and the waste heat from that process was used then to provide space heating to the building. But in an Irish context, though, the key thing we picked out from that project for industrial heat pumps are drivers and barriers. So there's a stated ambition at national level that 75% of the electricity in Ireland should come from renewable sources by 2030. And another driver then would be coming from the industry themselves, their need to reduce running costs, or their need for a greener footprint. So against that, we have the barriers, such as has been mentioned a couple of times, the fact that Ireland was red on that map. Our relative price between electricity and gas is very punitive when it comes to justifying heat pump projects at a large scale. We've also seen in some of our other work, which I'll talk about in a minute, relating to energy management processes within manufacturing companies in Ireland. There's traditionally a slow uptake in those processes. So it was mentioned earlier about the need for energy audits and to have them properly implemented. It tends to be not in a widespread way anyway. We're not advanced in that sense. And then the final barrier I'd mention are electrical grid and generation constraints in the short term, that our network requires a lot of investment to bring it up to speed. The research work that we do then, the skills side of it has been a very strong platform, but we've also carried out work on the technological side. So in our human tech project, we're looking at automating construction methods for the benefit of health and safety and efficiency. But coming on then to heat pumps, and we have carried out a number of data-driven projects where we focused on residential heat pumps, but I think there are a lot of lessons that we took from that data and the analysis of the data that is very relevant to the deployment of industrial heat pumps. So the FACT HP project, which is shown there, it was funded by our National Energy Agency, and they wanted to compare the real world performance of heat pumps to their software predictions, so for space heating and for hot water. And it was the first time that they had real data to compare a system that had been in place for a number of years across a range of ground source and air source heat pumps. And we found some very interesting findings. Even just a couple of graphs there, you can see that in one mode of operation, performance might have been very optimistically predicted, whereas in another mode of operation, the opposite was the case. So this kind of data-driven research is core to what we have been doing for a number of years, and I think I'll make a couple of observations about how that can impact, or it needs to be taken into account for industrial heat pumps as well. So some of the key lessons that we've taken here is focus really on, it goes without saying that design, installation and handover needs to be of the highest standard, because heat pumps are coming into organizations where generally the staff are not familiar with how to operate these systems. So it's really important that the design has been well thought out, the installation has been carried out to the highest standards, but that the handover and that the ongoing operation is very well understood. This can be helped by ensuring and insisting that performance verification is included from the very outset, so that we have proper thermal and electrical monitoring with proper data logging. I think this is one of the key things. I think the graphs I'm showing there give an example of a heat pump system which had a lot of oversight in terms of engineers and quality assurance and installers. And yet the top graph shows that the system was forced into a lot of on-off cycling. Its temperature never achieved the target temperature over an extended period of time. And that was purely down to, inadequate handover and, over-optimistic maybe commissioning. Whereas if with the optimized approach, the lower graph was achieved, where the compressor output, it rose to a maximum, it then modulated down, and eventually it switched off and on the top of the graph, you can see that the target temperatures were achieved. So it's a very simple example from a residential scenario. But I think for heat pumps across the board, no matter how big they are, something like this will take place, that the operators and the owners will need to be aware of, making sure that they work properly. And that will require ongoing vigilance and operational management at a new level of skill that maybe that doesn't already exist in those organizations. So when the installation companies leave the scene, who is going to make sure that this system continues to work? From our Horizon 2020 project, Speedier, we focused on energy management in manufacturing sector. So we found that the majority across countries, Ireland, Italy, Spain and Romania, the majority of companies at that stage had not carried out energy audits. We've subsequently, with working closely with a number of companies, we found that audits were done just as a box ticking exercise, and measures were not really properly planned out or not implemented. So the key thing there is that a culture of energy management needs to be driven from the top. It needs to come from top management to provide time for staff so that they can make the right analysis of their current operating situation to see if a heat pump is the right thing for them. And then when they move on to that they need to be sure they have baseline data, that they know what the old system was consuming in terms of its energy, and going back then to monitoring the new collection of new data to ensure that they're on the right track, that they continue to make energy improvements and that they maintain the system efficiencies that are designed into the system. So that can either be done by in-house staff, or perhaps there's some kind of a energy procurement contract in place, in which case the host organization needs to be very clear about the contractor, if they're paying by kilowatt hour or paying by efficiency or whatever. So just to conclude then, a couple of examples from actually on the ground. There have been commercial sized heat pumps, we would say. They have been installed going back for 20 years. They have had government support at a couple of times. The current support is called the Support Scheme for Renewable Heat, where heat pump systems can avail of a 30% capital grant. We've many examples around the country in the range maybe 30 to 500 kilowatts, and a few not that many in the range above 500 kilowatts. In the years up to 2011 or 12, they were predominantly ground source, but then in more recent years, air source technology has really taken over, and it's very suitable to our climate in Ireland for heating. And in commercial buildings, we have requirements for cooling as well, but heating is the larger user over the year. And finally, when it comes to commercial or industrial heat pumps, there have been a lot of barriers that have held back growth in this sector. So for that reason, case studies are hard to come by. project owners who are willing to share specific details are also hard to come by. But there are some examples that we know of in the dairy sector, which is a very important energy user, a big, large energy user in the Irish economy, and also in the FDI, biotech or medical devices sector. And then also in data centers, we have coupled with the growth in renewable electricity, we have a challenge where we also have a large number of data centers. So there is a big emphasis on trying to recover waste heat from data centers. And I just show an example of a project which is currently in the tendering stage and will be installed next year for a manufacturing plant. That if you just consider on the right hand side you have the cooling headers, and on the bottom right hand side you have the heating headers. Heating was totally looked after by, well, it was looked after by gas boilers and a CHP plant, whereas the cooling load, which is critical to the processes, was looked after by two separate air-cooled chiller systems. So in this reconfiguration, they have taken out the CHP and they have included some new water-to-water chillers here to take over half of the cooling load. And in between the heating and cooling side, then they have installed a water-to-water heat pump. So they will basically use that to recover as much waste heat that would otherwise be dumped to the environment and put it back into the heating side, where it can be topped up by gas boilers if necessary. And in addition to that, they have installed a large bank of air-to-water heat pumps as well. So their goal is to totally minimize the use of natural gas and I suppose electrify their system as much as they can. So that's all I have for you today. Thank you for listening, and we'd be happy to take any questions afterwards.
Thank you, Padraig and Seamus, for this very interesting presentation. It was actually interesting to see, Seamus, the projection of the deployment of industrial heat pumps from now to 2050. And I really appreciated the focus on skills and from Padraig, because it was actually a topic that was mentioned by several, by almost all of you, all of the speakers. So yeah, it's important also to give visibility to projects that are working to promote skills in the sector. So before moving to the Q&A session, here's the banner. I really hope that these presentations, I want to thank all the speakers for these presentations, and I really hope that they were interesting for the audience and that you gained some relevant insight. When we were organizing this event together with Irene, we thought, let's not just focus on the challenges, on the bad things, on the barriers, but also on the positive things. So on the incentives that are in place and on the opportunities that are available. So I hope that we could answer, our speakers could answer to these two topics, let's say. And now, as anticipated, let's move to the Q&A. So I saw that there has been some exchanges in the chat. So I'm very happy to see that the audience is engaged and that the speakers have already answered some of these questions. Before seeing if there's anything that has remained unanswered, I have a question for Veronica. And so thanks, Veronica, for your presentation. And I wanted to ask you, which are the industries that are more well suited for heat pumps?
I think we have seen today a couple of very relevant and interesting examples. So basically, we can use heat pumps wherever we have waste heat available and where there's a heat demand, I would say below 200. Usually this is more an economic threshold than a technical threshold. So we have seen examples from the dairy industry. Food industry is very relevant because they use heating and cooling. The paper industry is one of the examples that comes up very often, but also chemical industry. And I'm sure that there are many other processes that can use heat pumps as well.
Thank you very much, Veronica. And I now have a question for Jan. And so, Jan, in your presentation, you mentioned the decisions from the French government regarding decarbonization. So my question is, when are these decisions going to be implemented?
Concerning these decarbonization decisions, Mr. Le Maire, our economical minister, has already confirmed that the text was voted in the last October, and now what we call the decrease will be implemented within the next 6 months. And concerning the tax incentive, they promise to engage this one from the 1st of January 24.
Okay, so very soon. This is good.
This is a concrete yes. This is a concrete action plan. This is we already can count on him just to promote, of course, every topics towards the decarbonization. This is the tools that we want to use in the French market for sure.
Very interesting indeed. My next question is for Jonathan. So Jonathan, in your presentation, you have described the SDE++ subsidy that has been active for more than 15 years in Netherlands. So my question is, what are your expectation for the future development of this subsidy, and how would this affect the implementation of the heat pumps in Netherlands?
Yes, thank you. Interesting question. Yes, so this SDE subsidy scheme at the moment is a premium subsidy scheme, and the government covers the loss in market value. So if there is less market value produced, then the government covers this. But at the moment, there's of course also a lot of attention in the EU for contracts for difference, for two-sided contracts for difference, where the government covers the loss if needed, but also if there is a lot of gains from a certain technology, then this also should be covered. And that's also trickling down to the SDE++. So that would mean that quite a lot of these parts of this subsidy scheme would have to be changed again towards this contract for difference scheme, and we will be working on that. Yeah.
Yes, you did mention it was changing together with the technologies and stuff, so it's yeah, understandable. And
it's always evolving.
Yeah. And next question is for Fabian. So Denmark, you said, will introduce a new CO2 e-tax by 2025, and this tax will be in addition to the EU ETS. So my question is, how is the acceptance of this tax in the industry?
Yes, thanks a lot for the questions. Yes, so we will get this CO2 e-tax, which will be around 100 euros per ton of CO2, fully implemented by 2025. And large part of the industries are not against this tax, because some of the income of this tax will be redirected again to industry to help them make the required investments to decarbonize and reduce their emissions. And these industries where it's very difficult at the moment to decarbonize, for example, cement, steel, everything with high temperature processes, they will get a reduced tax rate at the beginning, and which will gradually increase as far as we assume technologies will mature to help these industries. Yeah.
Thanks a lot, Fabian. And my last question goes to Seamus and Padraig. So you have described the Irish case, and my question is, how do industrial companies in Ireland develop heat pump projects? I don't know who wants to answer.
I can take that. Yeah. I think it generally it'll start with the top management, and if they have an engineering in-house team, they may gather their data internally and prepare initial case studies, but typically it goes to an external consulting firm then to organize the design and tendering process, and searching the market for suitable equipment. But there will need to be at some point a decision where the manufacturer of the specialist heat pump becomes much closer to the design process.
Indeed, this is something that we're also addressing with our two projects, Push to Heat and Spirit, that, as I introduced earlier, are actually going to work towards fostering the the deployment and installation of integration of high temperature heat pumps in the industry. So yeah, it's reflected in the projects, I guess. I don't know if there are other questions in the chat. We're approaching the end of this webinar, but I think that all questions have been answered by our speakers. Thanks a lot for doing this. Otherwise, we couldn't fit all the questions in this 15 minutes Q&A session. So I think that we can close this webinar. Thanks a lot to the speakers, to the audience, to Irene that is here and has helped organize this amazing webinar. I really hope that it was insightful for you. And yeah, just I will change the slides to allow you to scan these QR codes that will redirect you to Push to Heat and Spirit websites, social media pages, and also the possibility to subscribe to the newsletters. Again, the slides and recordings of this event will be shared with you in the next days. And so follow EHPA to know more about our mission, what we do, and the upcoming events. And I wish you all a great rest of the day. Thanks.
Thanks a lot. Goodbye.
Thank you.
Bye.
Bye-bye.